Okay, today is a review day because what did you just take yesterday? Probability B, the big probability, the hard probability test. You're going to get those results back today. And then the plan you will be following here is in the class we work on this worksheet, which is a review of all that probability stuff. It includes the other probability test, which frankly was way easier. I mean, the stuff you just did, that was way, way, way harder. So your main job for today is to look over your tests, the answer key, make sure that if you did have some trouble with it, that you fix those, and then you learn that stuff, and then you take another test. And that can count as a retake. I am not going to require test corrections, although if you're in class today, I am going to require you to start test corrections. So come on, you really should do it. The only reason I'm not really requiring it is there's some kids that are gone today, and that's going to make it very difficult for them to even qualify for a retake. That wouldn't be fair. So I'm not going to require test corrections. I'm going to encourage you to do that during class today because it'll help you learn the stuff. If you correct those mistakes, it'll be questions just like that on the other test. All right, so anyway, that's the plan for today. So let's talk about what was on the other test that wasn't on this test. Because I'm not going to do a complete review of yesterday's because you just took the test. You know what was on it. In fact, if you need review on that, look at the day before. Go back a couple days on the videos. There's a review day that covered everything that was on that test. CC over C and all that stuff, that's all covered there. But let's review the old stuff. All right, in case you forgot, there was Venn diagrams, tree diagrams. Those are the main two things, okay? So let's do a Venn. Let's do people that own a dog and people that own a piano. And some people will own both, and they'll go in here. And some people won't have either one, and they'll be down here. All right, so in this room right now, we have a small number of people because a ton of people are taking the AP test. So in this hour, we have 2, 4, 6, 8, 10, 12 people. Nice number, anyway. So how many of you have a dog but not a piano, and therefore would go here? 1, 2, 3, 4, 5, 6. A keyboard would count as a piano. All right, so we'll move you. All right, I'm going to do that again. A keyboard would count as a piano. Raise your hand if you have a dog but not a keyboard. I'll say it that way. 1, 2, 3, 4. Thank you. How about if you have a dog and a keyboard / piano? You got both. 1, 2, 3, 4, 5, 6. How about you have a piano / keyboard, but you do not have a dog? All right, 2 people. And I think that's all 12 of you. Is there anybody that I missed that doesn't have a dog and doesn't have a piano? All right, so then we have 0 down there. So then here were the questions that are on this type of thing. First of all, dog, piano. What's the probability of a dog and piano versus dog or piano? There's a big difference. Hopefully you remember the difference. I'll explain it in a second. Dog and piano. Probability of dog or piano. And remember, you can ask them. I think it's a really good method. Like, go in this little area and say, ask them the question. Do you have a dog and a piano? And then you decide who's in the group and who isn't. Remember, it's out of 12. I usually like to put that at the upper left-hand corner. All right, so this is a review of Venn diagrams. Try to answer those 2 questions, and then it's going to get harder. I'll pause for a second while you try that. Okay, here's the difference. And means they have to have both. So this is a small answer. It's only this. So 6 out of 12. Raise your hand if you had 6 out of 12. Awesome. Then ors are big answers. And ors you add this. That's also included in the or because ask them. Do you have a dog or a piano? Unless they're a real jerk, they say, yeah, I got a dog actually and a piano. But if you say they would be unlikely to respond to you and say, no, I don't. I have a dog and a piano. All right, so anyway, or includes all of them. 6, 7, 8, 9, 10, 11, 12, and that would be 12 out of 12, and that's the rare 100% or 1.0 probability. Now, we can have them in the math classroom, but then it's really, really, really rare to have them in real life because there's always something strange that could happen. All right. So now we got to do ors. No, we already did those. Now we got to do symbols. You get that and would have been that, And I like to think of it as kind of like A and D, you know what I mean? That's like an and symbol. And if the or symbol, of course, must be the other one, it's like this. That's or. Okay? And another name for that is union. And this kind is called intersect. All right. Now, let's use the same data that we have here and do a given. So, I have polled all these people. I already know a lot about, what they have at home and stuff. Let's say I'm only going to ask the dog people, given dog, who has a piano? So probability of a piano given dog. As soon as I said given, that changes the denominator. It's not out of everyone anymore. So you have to divide by something not 12. If they say the word given, you can't divide by 12 because what's possible, that's what goes on the bottom. That's what you want over possible. What's possible is not 100% anymore. It's not all 12 people are possible. All right, given dog. Did you have? Are you actually doing these? I mean, I know you're messing with those things, but are you doing these problems? Okay, good. So what'd you get for piano given dog? 6 out of 10 is correct. Raise your hand if you guys had the same thing. Awesome. Okay, you see how much easier these are than those ones we just finished? All right. So I'm not gonna say the problems that were most missed on last night's test because some kids haven't even taken the test yet. Okay, but I am gonna do an example of the kinds of questions that I had a lot of people ask about. All right, one was on the 3-digit number kind of question. Okay, let's say I give you a 4-digit number this time. Okay. And in a 4-digit number, how many of them would there be that would be possible? I'll start with an easy one. And unless I said something, numbers can repeat. I mean, like why wouldn't they be able to repeat? Unless I would say that they can't. So numbers can repeat. How many different possible numbers are there? Just numbers, yes, not numbers and letters. Or if it's just numbers, it'd be 10, 10, 10, 10. Think of that as 1 times 10 to the 4th. You move the decimal over 4 spots. 1. There we go, 10,000. 10,000 possible combos. And I know it seems like, but wait a minute, Mr. Server, there's only 9,999 is the biggest number you can have. But you can also have 0, 0, 0, 0. So there is 10,000 of them. All right. Now, here's the question that would be much tougher. If you know your friend guessed a number bigger than 7,000, now what's your probability that you are going to guess their number? You know because you cheated. You looked at your friend's number and they wrote a number down. It was a 4-digit number. And you knew it was bigger than 7,000. Now what's the probability you guessed their number? There was a 4-digit number. Remember, it's always what you want over what's possible. And I'd usually start with the bottom, what's possible. Is there 10,000 numbers possible anymore? No, because given that theirs started with what? 7. And we're assuming you can use all the digits, so 7, 8, or 9 would all give you big enough numbers for a starting number. So then how many choices are there for that first spot? 3 choices times these other numbers can be anything. 10 choices, 10 choices, 10 choices. Do you get how many numbers there were that were an option? All right. 10 times 10 times 10 is 1,000, times 3 is 3,000 numbers. And that makes sense if they start with 7,000, right? From 7,000 up, that's going to be like 3,000 numbers. Okay, so there was 3,000 numbers possible. How many of them did your friend pick? Just one. One out of all that. How many of you would have got that one right? Okay. All right. That was one of the ones that was most missed on the test, is something similar to that. Another kind of most missed question. Let me look. You guys did really well on those expected value questions as a group, that is. The defective one. I knew would get people, but did again. All right. So let's do a defective question, because that's another one of the most missed. All right. So imagine for a moment that we are, what are we buying this time? I've done iPads, I've done phones, I've done a bajillion things. Toasters. Okay. Haven't done that in a while. All right. So I get, let's say that I buy, I'm trying to do this, recreate this experiment where my friend was using a toaster at my house, and he wisely, when he got his toast stuck the knife down into the toaster to try to get the bread out. And yeah, and he did not die, but it gave him a wallop of a shock. And here's the weird thing. He didn't know what happened. What, from his perspective, he still didn't know that that was a dumb thing to stick a knife in a toaster. He found it out at my house. Anyway, so he was like 15, so he should have been old enough to know. Okay. Well, anyway, so he sticks the knife in the toaster, and he gets a huge shock. Thankfully, he didn't die, but he gets this huge shock, and he feels it in his arm. And so what he thought is that somebody had hit him. It had the same feeling as somebody smacking him. And again, he didn't think that anything was going to happen when he stuck the knife in the toaster. So he didn't understand why the back of his arm just like had this searing pain, and he thought somebody had just like smacked him. And he turns around, he's like, "What?" And it's like, "Somebody just hit me." And they're like, "No, we didn't just hit you." We see him with the knife in his hand, like, "You didn't just stick that in the toaster." "Yeah, I stuck it in the toaster." Okay, so anyway, so we got, let's say we have 10 toasters, of which one of them is defective. All right, so there's our base of our problem. We got one defective toaster somewhere. Don't know which of the 10 it is. They all look like they work. What if you grab 3 of them to give as wedding gifts out of the 10? What's the probability one of the 3 will be defective? I'll say this again. There were 10 toasters in the pile at the store. Turns out one of them is defective. What's the probability that if you give 3 out as wedding gifts to your bridesmaids or something, that would be the worst bride's gift ever, but that you give them one that is defective? Now, hint, this is a CC over C. If you haven't figured that out, it's a big group divided into subgroups. Yes, that's how you do this, CC over C. So you've got defective things and not defective things. That's your 2 subgroups. And then all of the toasters total at the bottom. And pause for a second while you give this one a try. And don't ever stick anything in a toaster. Pausing. Okay. Toasters. I'm going to call these defective and these normal. And there was 1 defective and there was 9 normal. And that makes a total of 10 toasters. This is total, or what's possible. And we wanted to give how many gifts out? 3. And then that means we have to add these 2 add up to 3, and it's 1 defective one, and that forces this. I never said there was going to be this, but you could figure it out. If there was 1 defective one, it had to be 2 normal ones. There we go. How many have set it up right? All right. And even after that practice, only 2 people set it up right? All right, I think we need to do one more that's like that. Do you get what just happened there? There was a total of 10, and we picked 1 defective one, and that forced it, since there was a total of 3 given out, 1 was defective, that forced that number to be a 2, because this plus this must equal that.
I think it's just hard to figure out.
The top part? Is the top part the hard part? All right. Well, the bottom part is there's 10 toasters and you're going to give 3 of it as a gift. So yeah, that's pretty much the easy part. And I do tell you, start with the bottom. Then you just got to figure out these two numbers have to add up to 10, right? All right. So let's try one more like that. This time, you order a whole bunch of tennis balls because you're the tennis coach. And you have ordered a set of 200 tennis balls. You figure that there's probably 1% of them are defective. Let's just do it in your head quick. How many is that are defective then? If it's 1% of 200 would be 2. So what percent defective did I say? 1% defective. So that means 2 tennis balls are defective. All right, so you got 200 tennis balls. We already said about the defective rate. You should be able to handle that. Now, let's say that you coach the girls' team, and your girls have just grabbed 40 of them to go practice with. What's the probability that they get both of the defective balls? I'll say that one more time. Out of the 200 tennis balls that you just bought, 2 of them are defective. They're kind of flat. If they grab 40 of them, then what's the probability they get both defective ones? Now, we are picking from the toughest of the tough. I know these are tough. But with that practice, I hope you could figure out how to set up your CC over C. All right. If you haven't already, label them with defective and normal, because that'll help keep you organized. People that don't have this organized aren't going to get it right. So it's an option. You don't have to label those. But all right, defective ones. There were 2. And then my advice was to go to the bottom first. So I should probably do that. It's out of, what's the biggest number we have? 200. And then we're choosing what out of that set. A total of 40 of them. And now I just got to go up and figure out how to make this and this make this. Right? So 1 plus be 198. And then how many defective ones do we, what's on the top is what we want, right? How many do we want? 2. And then how many normal ones does that force us to have? 38. Raise your hand if you set that one up right. Okay, good. Now we're better on that. Okay. Yes?
So why wouldn't we do like the 40 C 2 and then the percentage of getting the effective one?
How about this? If you want to see if that way works, I will admit there is more than one way to do these problems sometimes. I don't want to try to explain more than one way because people can mix up the ways. But if you get the same percent as you do when you try this, then I'd love to hear you explain it to me. Okay? So I don't like to explain why is this wrong because people start thinking that I heard Mr. Server teaching it this way. So if you can make sure that your way works and gives you the same percent as this, then I want to hear it. All right? So double check that and see if it comes out the same. Then I'll answer you then. Okay. So last thing is big complicated trees. I don't want to have you make one right now because they take too much time, but I'm going to make one. Boy, girl. I'm going to pick 2 kids in class, and do you get that I'm either going to get a boy or a girl on my first pick? And this is boy, girl. Yeah, so in this class, we have 1, 2, 3, 4, 5 boys. That works pretty good, actually. So then there's a 5 out of 12 chance that I'll pick a boy, and there must be 7 out of 12 chance I'll pick a girl. Now, assuming that I can't pick the same person twice, I'm trying to get a group of people together, right? I'm trying to get 2 kids. So I can't take the same person twice. Would you fill out the rest of this chart and get the little decimals at the end And then I will ask you questions that would be typical of the big tree diagram questions. Hint, it's not out of 12 on the second choice. You already picked a boy. Here, you already picked a boy when you went this way, so there's less than 12, there's 11 now. And there's less boys out there too, because you already picked one of them, and you can't pick the same kid again. All right, I'm going to pause for a second and try to fill out this chart. Okay, you should have said that since you picked a boy already, there's less boys out there now, so there's only 4 left. 4 out of 11. Did you catch that? Yeah. All right, good. Then on the girl choice, there is still 7 girls because we already only picked a boy, right? So there's 7 girls out of 11 for that option. Down here, since we picked a girl first, there were still all the boys, which is 5, but there's only 11 kids left. And then this one should have been 6 girls left because you just picked one, and there's 11 kids total. Then the decimals, dice of destiny. Who should I call on? And it is row 2, person 2. That's you. Do you have the top one, Sam?
Yeah.
Excellent. What is it?
0.15.
0.15. Can anybody verify 0.15? All right, good. Next one.
0.27.
Awesome. Keep going.
0.27.
And I know some of you went 3 decimal places, which is awesome, but this is okay. Keep going. 3.2. Okay. Why was it most likely that I would get 2 girls? There's more girls. But actually, the thing it was the most likely was 1 boy and 1 girl. Like 2 boys was very unlikely because there weren't that many boys. But if you were asked this question, what was the probability of getting a boy and a girl in any order, then you would have added these 2 together. Because either this or, and what does or mean? Add that. Okay, so you'd say 27 and 27 would be 40, 54. 54% chance. Okay. Now here's one. Probability that I would pick at least 1 girl. Don't say it, think it. Probability I would get at least 1 girl. Do you have an 85 in your head? Excellent, because you're doing 1 minus that one, I bet. Or you were doing this, or this, or this, and then you'd have to add these 3 things together. The smarter way would be to just say 1 minus that one. Okay. Now here's a tricky one involving given. Given that you saw me start the pick, and you know I picked a girl first, what's the probability it's going to be girl, girl? And you can't say it's 32, because it changed as soon as I said given. Given that it was a girl first, what's the probability it's girl, girl? Remember what given changes? It changes the denominator. It changes what it's out of. It's not out of everything anymore. It's only out of these 2 because I picked a girl first. So what do you do to those 2? Add them and put them on the bottom. And then, what did I want? Girl, girl, so it would be 0.32 out of 0.59. Yes, good. Okay. Final answer, point what?
0.5.
All right, good. Now, some kids will do this a different way. There is other ways, but this is my favorite way of doing it. Other ways would have worked. If you, as long as you get the same final answer of 0.5 what? 542? Okay, good. All right. Well, there is a review, and we did just decide, just minutes ago, to move the cumulative. I'm putting on the video here too, so it's kind of committed. We were going to do the video, or the cumulative, on Monday. We have moved it to Tuesday. So that means tomorrow's class, even though tomorrow is actually on Monday, you know what I mean? The next class you have will be another review day like this. You guys will be ahead of the game because you've already reviewed, and you could have just taken it on Monday. So you will have a day where it's mostly hand back the test, which I'm going to do for you right now. Hand back the tests and do corrections. You can get them again on Monday if you need that much time, because some of you did do pretty bad. Most of you did great. But if you need both days for corrections, hey, you can do that. All right. So we're going to do corrections on your tests, and then Monday is another review day, and then the cumulatives on Tuesday. Then after that, you'll do 3 days of stats with Mr. Winterhalter because I will be gone. Remember, I've got my son graduating and getting married next week in Colorado, so I have to be gone. That's all I got for you.